this second installment of my videos about solid programming, I will be talking about the rest three of the 5 solid principles. As you may remember in my first video, that the first one is in the solid was a single responsibility principle, and the O was open closed principle, and the third one was Liskov's substitution principle, and the fourth one was interface segregation principle, and the last one was dependency inversion. Dependency inversion. I actually talked about a little bit about all of them in my first video. So if you wonder, if you need some overall information as well as more detailed information about the first two, go ahead and check my first video, which I will put a description. I will put the link in the description box. So let's continue on the Liskov substitution principle. So the Liskov substitution principle is kind of a behavioral subtyping. So you know that in the object-oriented world, you have the option, you have the capability to override base classes and its methods, right? Sorry, not override base classes, but its methods. So let's say you have a class called class A or class animal. Okay, let's move this a little bit behind so that I can easily type. Actually, let me fix this real quick. Okay, so I'll just go ahead and okay, that has to be better. So let's say I have a class animal, and then it can have a method like let's say void public void. It basically doesn't return anything because it's void. And then let's say possibly eat something. I'm just making this up. I mean, it's more like a really natural video. I didn't write up anything in advance to prepare for this video. So it may take a while. I mean, the examples may not be that good, so please accept my apologies. So it just does something. It doesn't matter what it do. Okay. So I can have another class that is, say, maybe cat, and that is simply extending. In C# you use colon, but in Java you use extends keyword to inherit a type. So in this thing, I just say, of course it has to be virtual too in C# to be able to override methods. In Java you don't have to worry about it. It is by default overrideable unless you decorate it with final keyword. I'm talking about the methods, by the way. So if I just say public override void eat. So before I explain this example, or yeah, let's explain Liskov's a little bit more. Liskov tells us that you should be able to change any subtype without expecting a weird behavior. So that's why it is a strong behavioral subtyping, and that's what I'm trying to explain here. For instance, if you accept an animal to your method as an interface or as a base class, that of course what you might do is you will pass in different subtypes of that animal class, right? Like you may be passing cat, dog, whatever, human. So what Liskov says is whoever consumes your subtypes should be confident enough to use your methods without expecting any unexpected behavior, meaning that if your, for instance, animal has a method eat, then semantically all the subtypes do a similar eating thing, right? I mean, your method should not do, like, cat does not run when you execute the eat method. This is an unexpected behavior, and that's why Liskov says even not just the interfaces of your subtypes, but also behaviors of your subtypes should match as well. So you're not just overriding a method, but you also override a behavior, and that behavior should follow, whatever the abstract type or whatever your base class communicates to the consumer of your API. So that's pretty much it, I guess. There, of course. So if you are an experienced developer, what we do is in our methods we have some conditions. For instance, if you don't expect people to pass in, let's say, a zero value. For instance, if you're expecting an h to your method, and if you don't expect it to be zero, then we put some conditions before or after the signature of our method to make sure that what we're getting from the user of our method is correct data or is expected data. What if it's not an expected data? Then we simply throw an exception and say invalid argument exception, for instance. So as an example, let's say we expect some food here as an argument. Food. So you don't really eat a null food. I mean, you cannot eat non-existent food, right? So what you do, for instance, in our eat method, let's say I'm adding this over here. You say, I'm just, you can write your own convenient methods, but I'm just gonna suppose that I have a method called validate, and I say validate. What I'm validating is I'm expecting food to be passed in here. Food is not null. In the implementation of this validate, if this is false, then it throws an exception and says invalid argument exception. This is actually important. Why? Because you want your program fail fast. You want your program to bark or scream when there's something not correct, instead of gracefully or just eat up that error, eat up that unexpected behavior and continue its life. Because when that happens, when you don't catch a problem at the right time, it will occur in a later time where you don't expect it to happen. So that's why we are making sure that we don't pass around an invalid state. What is an invalid state? Invalid state means that the state of your object. What is the state of your object? Is basically you have an object with fields, right? Properties or fields that you use to store data. So for instance, if you have a class name A, it might have fields like public. Of course, in C# what's recommended to use is to use properties, but in this example I'll just use simple fields. So public int h, public string name. So let's say you have let's say you have a class like this. Once you instantiate this class and then initialize your data, these are, by the way, called fields, and you use them to store data. So let's say you have a equals new a, and you said a dot h equals 5, h dot a dot name equals Rocky. So this is called, and what you do here is that you define the state of your object, and the state of your object is age is 5 and the name is Rocky. So that's what I'm talking about when I say state of an object. And you don't want to pass in an object between your methods or between layers of your application that is invalid, meaning that you don't expect someone's name to be nothing, right? It has to be something. If it's nothing, then it is an invalid state. Of course, it depends on your program, but I assume that in my program, I don't expect people to have. I always expect people to have names. So anytime my object doesn't have a name, it is an invalid state. So if you capture that invalid state before you actually pass that object to some other responsibility or responsible party, then you will be easily capture the problems and fix them right in the spot, instead of letting them occur in a later layers, or in a different layer, in a different spot of your application, which might be misleading. So you don't want to be misled, obviously. So this is important, and we call this precondition or preconditions if you have multiple of those. So let's say you say, okay, people are, let's say we are getting a food object, and we don't want that to be null, and we validated it before everything else in my method, and that's called precondition, meaning that one condition of this method, a precondition of this method, is food cannot be null. It depends, you can have different parameters and you can apply different conditions. For instance, if you don't expect an integer type variable to be 0, then you validate it as a precondition to make sure that whoever consumes your methods are not passing in an invalid variable. So this is it. And the second thing, by the way, I'm still explaining Liskov's substitution principle, but it's important to understand, those conditions, because the conditions will also are important. Why they are important is because when you subtype a base type, you also make sure that conditions are also satisfied in your subtypes. So you may not lose up your preconditions or add different post conditions, which I'm going to talk about what they are, like post conditions. So if you remove one precondition, now you break the behavioral subtyping as well, because now your base class and your subtypes will behave differently. Why? Because they're now missing precondition. So you want to keep that in there as well. So for instance, if all of your subtypes not expect a null food value, but except for one, then that is not right, because whoever consumes your method will happily pass in a null object, right? And then we will say that, okay, this method works with a null type, a null value as well, until you pass in that specific type which does not accept null value, and here we go, your application will break, and you don't want that. So the post conditions, the second condition type. So we have three different conditions that can exist in a class. Preconditions, I've talked about them. Invariants, I'm going to talk about them. Post conditions, and let's talk about post conditions. Simply, post conditions are you do some calculations in your method. You call some API, get some data, and blah blah blah. And now you want to make sure that whatever you get from other APIs, other methods, other layers, interfaces, whatever, are what you expect they are. So for instance, in your, let's say, get name method of a profile class, you call into an API that hits database and get the name of a person based on the person ID. So if you get an empty string, this is not right. Right? If you get an empty string from the database, it is not right. So what you do is you make sure that you're not getting an empty string, and you can use, for instance, the same validate method to make sure that, and this is called post condition, because it happens right after your code in the method that you apply your post conditions to. You may have several different post conditions. I mean, you may be getting data from different places, and you may want to make sure that what you get is what you want, what you expect. So you check their validity, I guess a word like better, they are valid or not, by applying that validate method, and that's called post condition. And again, you cannot add more post conditions in different subtypes, because when that happens, you again break the behavioral subtyping. The last one is invariants, which are things are not allowed to change, like constants. For instance, number pi is always the same, and you should not change it, right? So it has to be the same value throughout your class, and that's why it's constant. So any constants in your class that should not change are called invariants, and you should not change those invariants in your subtypes as well. Okay, that pretty much explains Liskov's substitution principle. I think I'm not sure if I missed something. Wikipedia and other places where you need to learn Liskov's substitution principle. Okay, let's go to the next one, interface segregation principle. So, interface segregation principle simply means that you should have smaller interfaces that are cohesive, meaning that they only do one thing. No matter how small they are, they have to do one thing. For instance, if you have a profile interface, it's not right to make that interface deal with a different task. For instance, money, like depositing money. Profile interface should be dealing with just the profile in stuff, and it's good for a clear and clean API design as well. And also, if you see a class that deals with a lot of things, like it gets a name of a person, gets an age of a person, deposit money into his account, and then withdraw money from his account or her account, and all those things in one class, it's a bad class. It's bad because every class, as we explained in my first video, every class should only one reason to change. But now you have two reasons to change that class. If you need to change something in accounting, you need to go to that class and change the class. If you need to change something about the profile, like how you get your name, maybe you decided to get the name not from the database anymore, but from web servers or something, you have to go to the same class and change it. See, you have now two different reasons to change one class, and this is against the single responsibility principle. So from there, interface segregation helps us to at least clean out the API. Like we can have two interfaces, iProfile and iAccount, that both of them are inherited by that class I've just explained. And that way we only expose those two interfaces, and whoever consumes those interfaces will not know whether they are going to the same class. And when they, for instance, do like auto-completion on their favorite IDE, they will only see related and relevant methods. For instance, if they do a profile, they will only see methods for profile, and that's actually confusing. I mean, you're not confused a lot by profiles and accounts, because they're really well-known concepts. But when it comes to like more unknown things, uncommon things, you know what I'm talking about. You'll see what I'm talking about, because you will be like, I don't know what this is about. I don't even know why this method is in here. How they are related, any kind of thing. All those things will be confusing to you. So it's better to keep your API abstracted and clean. And interface segregation helps us with that. So the last one, dependency inversion. I'm sorry, I'm not writing a lot of code here, but it is ASMR, so you probably will listen to this while you are, I don't know, before you sleep, or you want to just, relax and learn something, in the meanwhile and stuff. So that's why I'm not writing code much. But so dependency inversion. Some say dependency injection, but dependency inversion is more like a it's broader. Oh wait, I couldn't pronounce it. More broad term. compared to dependency injection. So the idea behind dependency inversion is, well, it is not an easy concept to explain honestly, because there are books, articles, a lot of things about dependency injection, but I'll try to simplify it as much as I can. So let's assume that you are a chef, you're a cook, and you need ingredients, right? You need, let's say, egg. You want to make some cake. You need egg. You need flour. You need oil, and goes like that. So you have two options. You can either go to Walmart or any store to get those items, or you can tell, hey, I will make some cake and I need these ingredients, and someone will go and buy those things for you. Well, the second thing is obviously easier and more maintainable. Why? Because each time you need something, it will be provided to you easily, anytime, anywhere. And you can also, let's say that person only knows ingredients for cake. The person that that provides you with the necessary ingredients, but you want to make some, let's say, you want to use a different recipe this time, and let's say you want to make some pasta, and that time that person that does not know which ingredients to provide, but you can easily change him with someone who knows which ingredients has to be provided. So that gives you some sort of a flexibility at that point as well. And you can populate these examples. I'll probably cut that portion of the video. Okay, let's increase this a little bit. Alright, so the dependency inversion is pretty much similar. It just provides you with the necessary objects that are created for you, and then you can easily use them instead. It usually happens in, you can see some good examples online. It's really not that easy to explain it on a paper, but it's always best to get some examples. But the idea here is that you're not creating your object, someone else creates your object, someone else maintains the life cycle of your object. All you need to do is to just develop the blueprints and write if the class accepts some what's that called, parameters in the constructors, and then someone else will create an instance of those dependencies that will be passed through the constructor methods of your class. And the good thing also is that you can depend on interfaces instead of concrete classes, right? So in your constructor of your class, you only depend on those interfaces, no concrete types. And then somewhere else you can say, hey, for this interface, go ahead and use this concrete type. For that interface, go ahead and use that concrete type. And that gives you some flexibility, because you can easily change any concrete type with, you can use a different concrete type for an interface, and it doesn't affect the entire program, because you don't have to find all the usages of that concrete type anymore, because you don't depend on concrete types. When I say concrete types, I mean classes basically, but if I say interface, it is an interface, so that's all. So you only depend on interfaces. So let's summarize dependency injection. You don't depend on you don't create your objects. You only request them through a constructor. Someone initializes your class, provides those dependencies that your class needs. by passing those appropriate classes to your class, dependencies to your class, and you don't depend on concrete types. You only depend on interfaces, and someone or you possibly will bind interfaces to their to whatever concrete type that you want for that as an underlying type for those interfaces. And as I said, that gives you the flexibility to change a concrete type for interface without affecting your program at all. You also can, like for instance, without compiling your program, can change a concrete type for an interface if you, let's say, define those relationships in an XML file that you read in your application. Right, so even you don't have to compile or change anything in your app. All you have to do is just change the XML file and the relationship entry in your XML, and your program will start using a different concrete type underlying as an underlying type for interfaces that your methods depend on. And also for unit testing, dependency injection gives us the flexibility of mocking our objects easily. So, you may want to mock your concrete type so that you don't really, let's say, actually hit a database, but since it's unit testing, you just create a sample data and provide that data instead. All those beautiful things really comes with dependency injection or inversion. Anyways, there are too many things that I can explain with those three topics, but I just want to keep it short. Even though I try to keep it short, it's still too long. I'm sorry about that. I hope it's useful to you, and I hope you learned something today. And leave a comment, and if you have any questions, and please do not forget to subscribe, and let's actually spread the message, and hopefully we find more people who want to learn, who want to get relaxed while learning new things about programming. My next videos will be about data structures. By the way, I'll be talking about linked list, arrays, and stack, queue, and all those things. So stay tuned. Thanks.